last section is called factoring polynomials completely. It sort of is making sure that we always factor every polynomial as simple as it can get. Okay? And there's one more technique that we're going to learn today. I hope not. We'll see. I hope so. Is always, you always have to factor out a GCF. If you forget to do that, it messes up the whole rest of the problem. So factor out a GCF if you can. Then ask yourself, is what I have left a difference of squares? And if it is, remember it factors in a particular pattern so that you can get it down to two binomials. Oh, I forgot I changed this and made it into a tree. Okay, a binomial. So if you have two terms after you factor out the GCF, ask yourself, is it a difference of squares? Because difference of squares is always two terms. A perfect square minus a perfect square. And then you factor that accordingly. If it is a trinomial, so three terms, then you use like our X method. Just go back to the basics, use the X, put A times C in the top, put B in the bottom, and figure out your factors. And then today what we're going to talk about is if it is a polynomial. So if it is more than three terms, then we're going to factor by grouping. All right, so we're going to factor by grouping if we have a polynomial with four terms. So always look at your polynomial. Two terms, check for a difference of squares. Three terms, use your X. Four terms, we're going to factor by grouping.
I don't get it.
Yes. So what this looks like, again, is there a GCF? You always have to factor that out first. And then we're going to put terms into groups. So we're going to rearrange, if we need to, the polynomial so that they're near other terms that have a common factor. And then we'll factor out a GCF from each of those terms that have common factors and use the GCFs as a factor. Here's our example. X cubed plus 3x squared plus 2x plus 6. Now, this is a polynomial. It's more than three terms. And there is no GCF. So this would be a case where we factor by grouping.
But I thought you have to have a GCF.
You don't have to. If you do, you have to factor it out first. But there isn't always one. But there will be a GCF in a moment. Now, the reason we call this factoring by grouping is because we're going to group typically two terms and two terms together that do have a GCF. Right? So like the red terms have a GCF of x squared. Right? So let's call this, if I factor out an x squared from just that group, then I get x squared times x plus 3. Right? Do you get how we factored out x squared?
And then you can make it 2x
Yes.
squared.
Good. Now we have a GCF of 2 that we can factor out of the purple terms. If we factor out a 2, we get what?
X plus 3.
Okay, notice.
They have the same.
Yes.
Oh, wow.
So our factored form, watch this is the last step. This common factor becomes one of the factors in factored form. So x plus 3 is one of the factors. The other factor is going to be what's left outside. Times x squared plus 2. Okay. You're right. All right, here we go. We've got another polynomial. It's more than 3 terms. And there is not a GCF that goes into every single one of these terms that we can factor out, right?
Can you put X and Y together?
Yes. So in this case, we're going to want to rearrange. We can add in any order, commutative property. So we could rearrange this to say x squared plus x plus y plus xy, because now we can sort of put these in groups. This would be a group with a GCF, and this would be a group with a GCF.
Oh, they don't have to be side to side.
No, they won't necessarily give them to you in groups. You might have to move things around a little bit to make groups. All right. What's our GCF of x squared plus x? X.
to the first.
Good. So we factor out an x. When we factor out an x, we get x plus 1.
How did you get that?
We divided each of those terms by x.
Oh, okay.
We factored it out. What's our GCF of y plus xy? Good. So we're going to factor out a y from both terms. And we get 1 plus x when we divide each of these by y. Are these the same? Yes. They're not in the same order, but we can add in any order and they are the same. So one of our common factors that we're going to use in factored form is x plus 1. The other one will be what's outside of our parentheses, what we factored out. So then our other factor is x plus y. Do you see how we got there? Okay. Okay, so then this is sort of the final wrap up of use any method to factor. You have to figure out as you go what's the best method to factor this. The number of terms, as we talked about, you figure out where to start. 2 terms, binomial, look for a difference of squares. 3 terms, look to do your x. 4 terms, look to group and factor that way. Okay? Because the point of this is to get it down to the most simple factored form. All right. And of course, this is always what I try to remind everybody. Don't forget about difference of squares. Everyone forgets about it. You'll get down to like x squared minus 1 and you'll be like, I'm done. But you're not done. It's a difference of squares. Keep factoring all the way.
How's that?
X plus 1, x minus 1.
Can we do a couple more examples?
X squared
Yes.
minus 1.
So is tonight going to be the review?
No, because 1 technically has a little 1 above it.
1's a perfect square.
Because 1 goes into...
1 squared is 1.
Oh, yeah, that's what I thought. So,
So you
and then x is perfect.
Remember this little pattern?
Times x would be...
That's X squared.
Step 1 is always what?
GCF.
GCF. Is there a GCF?
Yeah.
Good. What is it?
6.
3.
Squared. X squared.
2. No, it's
3.
not
6.
3.
3. X 3.
It's 3x.
X.
Notice how every term has an x.
Oh, wow.
So this one, we have a GCF of 3x. Because every term has 3 as a factor, and every term has x. So if we divide every term by 3x, we end up with x squared plus 2x minus 6.
How does that work? Why did you just lose a... Oh.
Because 3x technically has an
A little 1 above it.
yeah. So when you do 3x times x squared, you multiply, and then you have an extra x. So you
How come
add.
the x doesn't just become 1 because x goes into x 1 time?
Because there's 3x.
Because you're putting x into x to the third. Right? So like look at my purple. 3x cubed divided by 3x, that's what we're doing.
Yeah.
Those cancel, become 1. Remember, when we divide, we subtract the exponents. X to the third minus x to the first.
How come you don't divide the... Never mind.
You subtract. When you have the same base, you subtract. So first we factor out that GCF. Then, now we're left with a trinomial inside of our parentheses. So what method should we use?
I just have to try.
Oh, the x. Yes.
So you divided by 3 each time.
Yep.
And then when you divided 3x by 6x, you got 2x, but
Uh-huh.
then when you divided 3x by 18x, you only got 6. Why doesn't 6 have an x?
Watch. 18x divided by 3x. What's 18 divided by 3? 6. What's x divided by x? No, what's it? 1. Anything divided by itself is 1. So that goes away, and we just get 6 times 1, which is 6. Okay, so then the diamond. For just the middle, we're only doing the diamond just for our parentheses. So we get -6, +2, 3 and -2.
You take the 2 from the exponent in the middle.
Nope, that's not right.
Oh, you divided. That's fine.
What is it? 3, oh.
That's all or 6.
Does it not go in? I don't think it does. So this might be fully factored. Remember we talked about sometimes you can't, there sometimes are non-factorable expressions, and this might be one of them. 3 and 2, 6 and 1. No, I think we're done. So you would leave this fully factored. Oops. Is this. You do have to factor out that GCF, but then we can't further factor that trinomial. So this would be your final answer because the diamond doesn't help us get any further factored. Okay? Factor.
No.
Factor this one. 7x to the 4th minus 28x squared. Step 1.
Difference.
It will be,
GCF.
but GCF first. 7x squared is the GCF, that's correct. 7x squared is the GCF. If we divide each term by 7x squared, we get x squared.
-4.
Perfect. X squared minus 4. Is this fully factored, x squared minus 4?
No.
No, it's a difference of squares.
Or whatever.
So wouldn't it be x minus 4 and then x plus 4?
Not 4. What would it be?
Why is it not 4?
What's the square root of 4?
Oh, 2.
X minus 2, x plus 2. You take the square root of that 4.
Because Eddie, you do like the binomial thing where you have the 2 by.
When we solve...
An equal sign. We gotta make it 0.
Yes, very good. We have to make it 0. So 2 x squared plus, or x, what the? I feel like I may have written this wrong.
No, you didn't.
I feel like this should be x cubed. I'm going to go ahead and make it an x cubed. Because I think that's what it's supposed to be. Minus 10x equals 0. Right? Got it set equal to 0. And then what form does your expression have to be in before we can solve factored form? We can't solve in standard form. We got to get this factored. So we're looking at 2x cubed plus 8x squared minus 10x. We need to find a GCF, which is what?
2x.
2x. Perfect. Start by factoring out our GCF. 2x. And then when we divide 2x squared, we get x squared plus 4x minus 5.
Why is this so difficult?
Well, it's the last one of the chapter.
This is the last one.
Yeah,
What do we do after this? Nothing.
take a test.
Well, what do we do after the test?
This isn't fully factored. We've got to look at that expression inside of the parentheses. -5 and 4.
-1 and 5.
Good. 5 and -1. Okay, and we have a 1 in front of our x squared, so we don't have to do our little division. So we get 2x times x plus 5 times x minus 1 equals 0.
Oh wait, we're not done yet.
We're not done yet. What's the last step?
You do x plus 5 equals 0 and x minus 1 equals 0.
Right.
Like, so
We have to set each of these equal to 0. So 2x,
So wouldn't it be x equals 5 and then x equals -1?
yep,
Or is it vice versa?
and x equals,
Is it positive or is
well,
it
careful. Remember, you have to also set, there's an x in our GCF that we factored out 2x. We have to set that equal to
Oh,
0
yeah.
and solve for x.
Wouldn't it be x equals -5 and x equals 1?
And watch on the left that I'm doing right now.
Wait a minute, so that would be 3x equals 5, and then
What?
3x equals 1, so if you divide it, it'd be 5 there is equal to
No. I think you're going too far.
No. Will there be problems like that?
Yes.
But I thought you had to put, like, let's say you have the 2x on the outside, you get to this part where you have the factors, where you have x, it's 2x plus 5, and you've got the little 2x multiplying it on the outside.
Yep. But don't distribute back in. Don't distribute back in. We want to get it fully factored.
So then you just put that.
So you factor what's in, you factor this.
So gonna forget
Now.
the last step on the test.
Yeah, what's the 2x then? You said we have to
That's your, yeah, so when you're solving, you have to set 2x equal to 0.
Oh,
You
so
have to set x
three
plus,
things.
correct.
So it'd be 2x, well then you couldn't have an answer divided by
2x equals 0, right? If 2x equals 0, then divide by 2, 0 divided by 2 is 0. So x equals 0,
So
x
0,
equals
-5,
negative 5,
-5.
x equals 1. So get the equation set equal to 0. We will factor out the GCF, which is 3x. So then we get x squared plus 2x minus 8 equals 0. Then we'll use our diamond method on the middle, not the middle, but on that trinomial. So -8, +2. And then our factors are 4 and -2. We take that, remember the reason we do the diamond is because then it tells us our factors, x plus 4, x minus 2. Yes.
Why would you do put 2 on the bottom because it says 2x squared? So what would you do with the square?
No, you factored out a 3x. Okay, remember, we're looking for 3 roots, or 3 solutions. So we need to set each one of these equal to 0 to get our solutions. 3x equals 0, x plus 4 equals 0, x minus 2 equals 0.
I was at the diamond and I got everything. I finished the whole diamond, but then I gotta get it back.
Yep.
And then I gotta do it again. Do the zeros.
Yes. So x equals 0, x equals -4, and x will equal 2, +2.
When do you do the thing where like you divide, like it's 3